Okay guys, in this video we discuss about how to extract the voice from audio file and how to reduce or how to remove the noise from the file and how to get a spectrograms waveforms. Okay, now get into the code. First, I was import numpy. Here, numpy supports the numerical computation array. NumPy supports the numerical computational arrays, often used for processing audio signal data, and matplotlib.pyt. Here it is used to visualize the data such as a spectrogram or waveform or plots of audio signals. Next, I imported Librosa. Here Librosa is a Python library for audio analysis, feature extraction and visualization, and commonly used for load audio and generate spectrograms and extract features like mild frequency spectral copy sound file. A sound file handles the reading and writing of sound files in various formats like WAVs and FLACs. Yeah, in this code we are using WAVs. If you have MP3 players, you can convert into WAV. It's free of cost. Next, import speech recognition. Here speech recognition is a library for speech to text conversion using APIs such as Google Speech API. From Jeever, here Jeever is used to compute evaluating the metrics for speech recognition such as a word error rate or character error rate, WER and CER. We will discuss these two on next video. And here from ipython.display import audio. It embedding and playing audio directly in Jupyter Notebook or any IPython environments. Import Whisper. Here Whisper refers the OpenAI's Whisper model, a neural network with speech to text transcriptions. And import CSV. It enabling and reading and writing from CSV files. Here I was import OS. OS is provide the function to interact with operating systems like navigating a file system. Next, I was importing temp file. Here temp file is used to create a temporary files or dictionaries. Wave. Wave is a built-in library for working with WAV files, allowing the low-level access to audio data. GTTS. GTTS, the Google text-to-speech library for converting text into spoken audio. I'll check. I don't know why it takes too long. Yeah. Next. Audio signal sample rate equal to Librosa.load of new project. This is my WAV file. Here Librosa.load. Librosa.load. This function reads an audio file and returns the audio signal and sample rate. Here audio signal is a NumPy array containing an audio item in a series of data, and sample rate. Here sampling the rate of audio file in heads. Now I want to check the sample rate here. Okay guys, this is the sample rate of the audio. Next, here first I want to hear the audio and I want a nice waveform figure represents the audio file with a nice title and labels. For that, I'll plot.figure and figure size should be 12-inch wide and 4-inch tall. Here plt.figure. Plt.figure creates a new figure for plotting. Librosa dot display. Librosa dot display dot waveform of the audio file. Here SR is equal to sample, right? Here Librosa dot display dot wave show. Here Librosa dot display dot wave show. This function visualizes the waveform of a audio signal, and it takes the audio signal numpy array and its sampling rate as an input, and generates the plot of the signals amplitude. Next, I want title as waveform. Label as time. Label as amplitude. Next I want to check here plt.show. This function in a matplotlib is used to display the plots have been created. If you are working in an environment like Jupyter Notebook, the plot will be displayed in a line or in a notebook. Next, the audio file should be the this is the audio file what I downloaded. Just a second, guys. Yeah, now we will listen to what is in the audio.
I'm AI interviewer, a content creator passionate about art.
Now here recognizers equal to sr.recognizer. Sr is initialize the new instance of recognizer class from a speech recognition library, which is commonly used for speech to text functionalities, and this object will be used to capture audio from various sources like a microphone or any audio file and to convert into a text. There is another recognizer, right? Yeah. Next, the file path should be your project.wave. Okay, now I want to extract the voice from the audio. Or file path is my audio file. Audio file should be export file path as source here. So here sr.audio file from the speech recognition library in Python is to load the audio file. This is commonly used for speech recognition task. record the source. Here audio data equals to recognizer dot record score is used in conjunction with the speech recognition library to record the audio data from the file. Next, text equals to here text is equals to recognizer dot recognize Google audio is used to convert the audio data stored in a variable audio data into a text using Google Web Speech API. The speech recognition library and the audio data variable should contain the audio captured and recognized and either from microphone or audio file. I want to print the text. Next, here return text, transcribed text should be like transcribe audio of file path. Here transcribed audio, it suggests that you are calling a function transcribe audio to convert the audio file located at file path into transcribed text. I will check it. One few seconds, guys. Why it's take too long? See, you got it right. This is the text in that audio file. Now we extracted the text from the audio file. Simple, guys. Next I will copy paste this again. TFT. Audio signal. Here Librosa.stft. It computes the short time Fourier transformation. STFT stands for short time Fourier transformations, and for the audio signal using the Librosa library in Python. Amplitude, here Librosa.amplitude. It is used to convert the amplitude values to a decimal dB scale. Now I will check it. np.max sub dB. Now here I want spectrogram. Same plot figure is equal to, I want same width and same tall, 12-inch width and 4-inch tall. Librosa.display.spectshow. Librosa.display.spectshow function is used to visualize the spectrogram like data as a heat map, and data equals to SB. This is the input data to be visualized. In this case, SDB is an amplitude spectrogram converted to decimal scale from the earlier step, and SR equals to sample rate. This is a sampling rate of an audio signal. It is used to correct the label, the time and frequency axis in the plot. And y-axis is equal to log. Log indicates y-axis should be displayed in a logarithmic scale. Here plot.color bar format should be, I want this type of format, +2 dot, this is the color, and here plot.color bar adds the color bar in a current figure, and color bar provides the reference scale mapping of the color intensity in the plot to a numerical values, example like decimals in this case. And I want title as spectrogram, and X label should be time, and Y label should be the frequency, and I want to show the spectrogram. What? Oh, okay, title. Okay guys, now just a second. See, this is how spectrogram look like. See, now I want to reduce the noise from our downloaded audio file. For that, I'll use Librosa.effect free emphasis audio signal and coef. Here Librosa.effect.freeemphasis applies the pre-emphasis filter to an audio signal. Pre-emphasis is commonly used for audio processing to amplify the high frequency components which are often lead during recording and transmission. This helps to improve signal clarity and enhances the certain features and analysis of processing. And audio signal and coef is the input signal in which the filter will be applied, and coef is a free emphasis coefficient that controls the filter behavior. The typical value of 0.97 applies a moderate emphasis to higher frequencies by subtracting 0.97 times to the previous sample from the current one. Here we will use sf.write. It writes audio data to a file, part of a sound file Python library which provide tools for reading and writing sound files. And filtered new project.wave, the name of the output file. Signal filtered, the pre-emphasized audio signal to save the sound by a numpy array of floating point values, typically in the range of -1 to 1. And sample rate, here sample rate of the audio signal, for example, actually we got 4800, right, sample rate. And next, output file, I named it as a filtered new project. Next, I want to play the original audio, so print playing original audio, and audio file is the file path. See,
I'm AI interviewer.
Okay, now I want to remove the noise from the audio. Playing filtered audio. This is the audio file after reducing the noise. Output file. Okay, yeah, capital.
AI interviewer, a content creator passionate about artificial intelligence.
See, we now remove the noise completely from the audio what we downloaded to remove, and removing the noise is completely easy now. In this video you learn how to extract the text from the audio and how to make waveforms, spectrograms, how to remove the extra noise from the audio. Hope you guys liked it and try it yourself. Download any MP3 and convert into WAV and practice this code, and see you on the next video.